let's talk about total number of selections. Now we are not talking about any constraint or any condition that has been given to us. Now let's say they've given us in a basket, let's say there are 2 mangoes, 2 oranges and 2 watermelons. So what are the total number of selections or total number of combinations in which I can select? Now they've not given us any information, whether I have to select 2, whether I have to select 1, whether I have to select 3 fruits out of that basket. So I would take each and every possibility and sum them up. So that time when no constraint has been given to you, that time your total number of selections becomes 2 to the power n. Simply, if you were to understand it, NCR. So NC0, let's say if I do not select any fruits from the basket, if I select 1 fruit from the basket, if I select 2 fruits from the basket, if I select 3 fruits from the basket, and this would go on up till NCN, till I select all the fruits from the basket. Now the sum of all these is equal to 2 to the power n. So remember this thing. Each object has 2 choices to be included or not included in the selection. Now whether I have 3 oranges, I will have to consider all those 3 oranges as different oranges. Now I'm not considering them to be similar. Therefore, for n objects, the total number of combination become 2 to the power n. Now let me give one more example for it to become more clearer to you. Let's say this is my basket. I have 2 oranges here, 3 watermelon and 4, let's say, mangoes I have. Now in the question what they are saying is, find out the total number of ways of selecting fruits, total ways of selecting fruits. Now how are you going to find out the total ways of selecting fruits? Simply it is going to be 2 to the power n. So for oranges it is going to be 2 to the power 2 multiplied by, since I have to choose each and every fruit, I have to consider each and every fruit, so this would become 2 to the power 3 into 2 to the power 4. 1 for oranges, 1 for watermelon and 1 for mangoes. Now what if I twist the question? Now if I were to give a catch in this question, and the catch is that every selection should have at least 1 mango. Should have at least 1 mango. Now what do you interpret from this? That means that in each and every selection I should have 1 or more than 1 mangoes. So how can I now calculate this one? Now this very simple way is that I subtract the number of selections in which I have no mangoes from the total number of ways. Based on that I will get the number of ways in which each selection has 1 mango, right? So that is what I'm going to do here. I'm going to subtract the total ways minus when ways in which no mango is there. No mango is there. So now what would be my total? Total is 2 square, 2 cube into 2 to the power 4 subtracted by ways in which there are no mangoes. That means first of all selecting the ways of oranges and selecting the ways of watermelon. For mango there are no mangoes, so it is simply just going to be 1. There is going to be no possibilities. That means what I'm trying to say is it is going to be 2 to the power 0. Since there are no mangoes, so I'm saying it is 2 to the power 0. Now if I try to find this out, that would be my answer. So I hope you must have understood. If sometimes a catch is given based on selection, so you do not need to calculate each and every catch by doing each and every, finding out the number of ways, finding out the cases that can be solved. Simply what you can do is you can subtract the total minus the complement of what the condition has told us. So keep this thing in mind. Now looking at this, the number of, again these are the same things repeated again and again, just to make you understand if questions are asked in different format, then what is the formula or what is the things that you have to do. Explanation: it represents the total number of arrangements of R objects selected from N where order of arrangement matters. Here order of arrangement is being mattered. However, when order of arrangement does not matter, that time we simply do it with NCR. Now for this one, for n factorial, this is the total number of ways to arrange n distinct objects when all objects are considered and order of arrangement matters. Again, order of arrangement matters, but all objects are considered distinctly. That time we use factorial. Now again, let's look at a few questions to clear our concepts more. A number is called a palindrome if it reads the same backward as well as forward. For example, 285582 is a 6-digit palindrome number. The number of 6-digit palindromes which are divisible by 55 is. So first of all, we need to identify 6-digit palindrome numbers which are divisible by 55. So for a number to be divisible by 55, it must be divisible by 5 as well as it must be divisible by 11. I hope you are getting this point. Now, since a number is divisible by 5, that means what is the last digit that can be possible? Either it can be a 0. Let's say if I am talking about 5 right now. Let's say if I have 5 at the end, or if I have a 0 at the end, then I can say that this two numbers are divisible by 5, right? Now since this is a palindrome number, that means whatever my last digit is, that would be my first digit. So 5 would be here and 0 would be here. Now I cannot take up this case, because if I take 0 in the first position, this would become a 5-digit number. And that is not what the question is asking us. The question wants us to find out the number of 6-digit palindrome numbers. That means only this is the case that is possible. That means we've found out our first and last terms. For each and every case, our first and last digit would be 5. So this is one thing that we found out. Now let us look for 11. Now for 11, what can we say? I hope you all know the tables of 11. Let's say if I multiply 11 times, what do I get? 1, 2, 1. Then what am I going to get? I'm going to get 132. So what is the one thing or the one difference that you are trying to find out in its pattern? That the sum of terms in the odd position is equal to the sum of terms in the even position. For a number to be divisible by 11, the sum of digits in the odd place should be equal to the sum of digits in the even place. Should be equal to the sum of digits in even place. That means based on this, what can we assume about the middle 4 terms that we are getting? That let's say if I assume this to be A, of course this is also going to be A, then this terms would become B. Now what I'm saying is that 5 plus B plus A, the terms in the odd position, should be equal to the sum of terms in the even position, A plus B plus 5. So you can see that these two are similar. That means this is the type of digit that I'm trying to find out. I hope you must have understood this thing. This is, now I've chosen A and B in such a way such that they are divisible by 11 as well. So we've gotten our 6-digit palindrome number. Now let us identify the cases in which we can put the values of A and B. Now A can vary from 0 to 9, and 0 to 9 can be the values of B as well. Now once I choose any one of the B, the other one would be the same one, so I do not need to take separate cases for it, or I do not need to take separate factorials or arrangements for it. So how many numbers can I choose for A? 10. And how many numbers for B? 10 as well. Now since I have to choose both these numbers, that means my total combinations would simply become 10 into 10, which is my 100. So there are 100 6-digit palindrome numbers which are divisible by 55. A good question. You must look at it and practice it once again so that you get exact the gist of what we did in this entire question. Let's look at another question. Two families with 3 members each and one family with 4 members are to be seated in a row. Now this is a question of grouping, what we call as grouping. Now what do we do in grouping is, let's say if I have 2, 3, 4 different objects with me, I group them together and then I consider them as one. Then I permutate it with other different objects as well. So this is a question of grouping, so keep this in mind. So they've told us that there are 2 families with 3 members each. So let's say in this family I have 3 members, member 1, member 2 and member 3. This is my family 1. In my family 2, again there are 3 members. They've told us that there are 2 families, right? So let me say this is M4, this is M5, this is M6. And in my family 3, they've told we have 4 members, M7, M8, M9, M10. So these are my 4 members. In how many ways can they be seated so that the same family members are not separated? Now first of all, if they would have told us that they wouldn't have given us any condition, then how many ways would you have told us? Simply, since there are 10 members, so it would have become 10 factorial. However, now they've told us that the same family members should be seated with each other. That means what I'm going to do is I'm going to group each and every family members. So this is my one group, this is my another group, and this is my third group. Now let's say if there are 3 different sections of seats, how am I going to group these 3 families? It is simply going to be 3 factorial. For first arranging the 3 families in 3 different sections, it would become 3 factorial multiplied by. Now since all the members must remain together, I am not telling that they are going to be different. I have arranged them in such a way, in 3 factorial ways, such that the members are together. Now each and every member can arrange themselves accordingly, right? So like M1, M2, M3, they can be seated either in this way, or they can be seated in M1, M3, M2, or M2, M3, M1. So for each and every family, there can be number of arrangements according to the number of members. So for first family, it would become again 3 factorial. For second family, it would be 3 factorial again. And for third family, it would become 4 factorial. I hope you must have understood this portion. First, what I did was I did 3 factorial. That means what I'm saying is either family 1, family 2, family 3. They are seated in this order, or they are seated in family 1, family 3, family 2, or family 2, family 3, family 1, or family 2, family 1, family 3. In any of, so there can be 6 ways, right, in which the families can be arranged together. So that is why we went on for 3 factorial. And then each and every member inside the family can be arranged in their respective seats. So for each and every family, the number of seats become their factorial. So upon solving this, whatever answer you get, that would be your final answer. I'm not going to solve each and every multiplication. So this is how you solve grouping questions. Now let's look at this. The number of 6 letter words formed using all the letters of the word vowels so that all the consonants never come together. Now if you look at this, WOVELS, so how many vowels are here? So I have 2 vowels, and my consonants are 1, 2, 3 and 4. So I have O and E as my vowel, and my consonants are V, W, L and S. Now what have they told us? The number of 6-digit words. 6-digit words with or without meaning, formed using the letter of the word's vowel so that the consonants never come together. So what am I going to do? Again, this is a question of grouping. Firstly, what I'm going to do is I'm going to find out the total ways of arranging. I will subtract all those ways in which the consonants come together. I hope you are understanding this thing. So to find out consonants never come together, what I can do is total ways minus complement of consonants never come together. And complement of consonants never come together is consonants coming together. So what I do is I group all these consonants V, W, L and S as one, and then I keep O and E separately. Now what are the total number of ways of arranging this? This would be 3 factorial for 1, 2 and 3. There are 3 different objects that I'm having, 3 factorial into, now I would have a 4 factorial as well. I can arrange the vowels inside accordingly as per their wish. So these are number of ways in which consonants are coming together. So the answer would be basically total ways minus consonants coming together. So from here, what are my total ways? Since there are 1, 2, 3, 4, 5, 6 factorial minus consonants coming together, 3 factorial into 4 factorial. So this would become my answer. If you solve this out, the answer is going to come out to be 576. This is your answer. So I hope you must have understood how we solve total ways minus complement questions and grouping questions. Now let us look at permutations of alike objects. That means, let's say if in a set, as I was saying, the number of ways of arranging any objects would be n factorial simply. Now what if out of those n objects, a few of them are similar? Then what would be my formula for arranging them? It would become n factorial by p1 factorial into p2 factorial into up till pk factorial. Now p is the number of objects that are same. So for example, let's say if in a basket I have 2 oranges, 3 watermelon and 4 mangoes. Now the number of ways of arranging them. Now I'm not talking about selecting them or collecting them. Earlier we had talked about arranging them. Earlier we had talked about selecting them. Now I'm talking about arranging them in order. Let's say first oranges come, then watermelon comes, and then mango comes. So that is what arrangement is. So what would be my formula for arranging all these things? In, let's say there are 7. So in 7 different places, what would be my formula for arranging them? It would become 7 factorial divided by, now since a few of them are similar, so it would become, since oranges are similar, so it would become 2 factorial. Watermelon are similar, it is 3, so 3 factorial, and mangoes are similar, so 4 factorial. So this would become my total ways of arranging them, arranging 7 fruits in 7 different places where there are 2 same oranges, 3 same watermelons and 4 same mangoes. So this is the formula that we use. Now another example has been shown here. If you have the word Mississippi and there are 11 letters in total, but some letters repeat. M appears 1 time, I appears 4 times, S appears 4 times and P appears 2 times. Then the number of distinct permutations is. So of course the number of distinct permutations would be total divided by the number in which they are same. So 11 factorial is the total number of letters that we have divided by the ones that are distinct and has same. So M appears 1 time, so it can be written as 1 factorial, or simply you can just eliminate it, does not matter. I appears 4 times, so 4 factorial. S appears 4 times, so 4 factorial, and P appears 2 times, so 2 factorial. So this is the formula that we use to identify permutations involving identical letters. Now let us look at this example. The number of arrangements of the letters of the word independence in which all the vowels always occur together. So first let us write down this word independence. How many letters are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 letters in total. How many are vowel? My vowel are I, E, E, E and E. So I have altogether 5 vowels in which one is I and I have 4 E's. And what about my consonants? I have of course N, D, 2, 3, 4, 5, 6 and 7. I have 7 consonants, out of which I've got 1, 2 and 3. 3 N's are there and 2 D's are there, 1 P and 1 C. So this is my distribution basically. Now what have they told us? They've told us that the number of arrangement of letters in which all vowels always occur together. So what am I going to do? I'm going to consider all vowels to be one in one single bag, I'm going to group them. So if I group them, I have I and E here. E is like 4 times basically. So this is my one distinct object now. I have N, I have D, I have P, I have C. These are all going to be considered to be one object. So 1, 2, 3, 4, 5. And N here I have 3 times. So of course this cannot be considered as one object only. N would be considered as 3 objects only. I'm not grouping N right now. N can be at separate places. I'm not grouping them ki N has to be together at all places. N can be at separate places as well, right? And D can also be at separate places. P is 1, C is 1. So what would be my total ways of arranging them? 1, 2, 3, 4, 5, 6, 7, 8. 8 factorial. Out of which I have N 3 times, I have D 2 times, I have PNC 1 time, so they do not matter. Now multiplied by, now this vowel here, the back inside the vowel, they can also be arranged in some format, right? So I have 5 vowels, so they can be arranged in 5 factorial ways, out of which 4 of them are E's, so divided by 4 factorial, and this becomes my answer. If you calculate it, it would come out to be 16,800. So this would be your final answer. So I hope you must have understood how we are grouping them, and then we are using this alike object permutations. Let's look at this question. The number of 3-digit numbers that are divisible by either 3 or 4. So you must understand this thing here. They are either divisible by 3 or 4. That means they are not divisible by both. That means whatever number I choose should be either divisible by 3 or 4, but it shouldn't be divisible by both. That means, what is their LCM? 12. That means it should not be divisible by 12. That means for 3 we are going to take those number. If it is divisible by 4, we are going to take that number. If it is divisible by 12, we are not going to take that number. And also, what have they told us? It should also not be divisible by 48. So for 48 also, we are not going to consider that number. So there are 4 different things that we need to find out. So first, let us find out what is my first 3-digit number. It is 100. What is my last 3-digit number? 999. So how many digits are there in total here? There are 900 digits. Sorry, 900 numbers, I would say. Now let's say if you weren't able to find out the total number of numbers between 100 and 999, what you can simply do is you can use your AP. You know the last term, you know the first term. It used to be a plus n minus 1 into d. What is your d here? D would be 1. So you could have found out your n. It would come out to be 900. Now first, let us solve for 3. For 3, what is my first digit that is going to be divisible by 3? My first digit would be 102. And what is my last digit that would be divisible by 3? 999. So how many terms are here in this? So simply let us find it out using AP. It would be 999 is equals to A, which is 102, is equals to n minus, sorry, this is plus n minus 1 into d. My d is 3 here. So upon calculating, what do I get my n to be is equals to? This would become 897 divided by 3 would give us 299 plus 1 would give us 300. So this would become 300. So that means I have 300 numbers, 3-digit numbers which are divisible by 3. So my n here is 300. Now let us check for 4 similarly. What is my first digit that is divisible by 4? 100. And last digit which is divisible by 4, it is going to be 990. 98. Is 98 divisible by 4? No, 996, sorry. So again, similarly, you are going to use here AP 996 minus 100 would give us 896 divided by 4 would give us would give us 2. So here our n would simply become 224 plus 1 would give us 225. So there are 225 3-digit numbers which are divisible by 4. Similarly, let us find out for 12 as well. What is the first digit that is divisible by 12? 108. And then up till what number is it going to go? Again 996. Yes, up till 996. So again, if I find out my n, it is going to come out to be 74 plus 1, 75. N would become 75. Now similarly for 48, I will find out what is my first term. 144 is my first term, which is divisible by 48. And what is going to be my last term divisible by 48? Let's see if 996 is divisible by 48 or not. If I divide it by 48, this would go 4 12s. Sorry. This would go on 4 12s, and this would become 4 2s, 4 4s 16, 4 9s 36, 3 4s 12, 3 8s 24, 3 3s 9. So no, 996 is not divisible. So then it would become 992. 992. Would that be divisible by 48? No. So 996 minus 12 would give us 984. Let's see if this is divisible by 48 or not. So let's go this 8 6 are 48, 8 1s are 8 2s are 16, 8 3s are. So again, this is not divisible. So let us subtract 12 once again. So we would get 972 divided by 48. This would give us 8 6s are 48, 8 1s are. Again, it is not divisible, so this would become 960 48. Yes, this would do it 20 times. So we would have 960 here, 960 in the last term. So if I start calculating up till 960, what is my n going to come out to be? It would become 18. So now we found out each and every number, 3-digit number, which are divisible by 3, divisible by 4, divisible by 12, and divisible by 48. Now as per the question, we have to take into consideration our 3, 4, remove 12 and 48, because of course they are going to be overlapping, right? Because 12, any number that would be divisible by 12 would be divisible by 3 and 4 also. Any number that is divisible by 48 would be divisible by 3 and 4 as well. So we have to remove those numbers. So from here, what do we get? This would make it 300. Our total number of outcomes, this would become 300 plus 225 minus 75 minus 18. Now, I hope you are understanding this thing. I have removed all those numbers which are coming out common in all these 3 sets, so that I can get the exact number and there are no common terms that are coming in here. So this would become 525, 525, this would become 450, 450 minus 18 would give us 432. This is my answer. So there are 432 3-digit numbers which are either divisible by 3 or 4. They are not divisible by both, neither they are divisible by 48. So this was a catch that you had to understand in this question. They had given us either 3 or 4, but not both. If it had been both, then they would have mentioned it separately, that it is also divisible by 12 as well. So that is why we had to remove 12, and for 48 they had already told to us in the question. So 48 gets removed from there.